Hello students, today I am going to start new chapter that is chemical bonding and molecular structure. This chapter is very important and also you all are familiar with this topic of this chapter. Some topics like chemical covalent bond, electrovalent bond like this. So at first we will discuss the what is chemical bonding. Let's start with the introduction. What is chemical bonding? What is chemical bonding? What is chemical bonding? So student, it is the attractive force. It is the attractive force which holds together the atom, ions, etc. in the chemical spaces. In the chemical spaces. Simply, suppose we have a cation and it has a P and there is a simple attractive force which exists between two spaces. This is known as chemical bond. Simply we can say that attractive force exists between two spaces, either it is atom, ions or any. So this is known as the chemical bond. So students, now we are to answer number of questions. Why do atom combines? Why do atoms combine? Why a definite number of atoms are present in a molecule? For example, hydrogen exists H2, not H2, not H3 or H4. Simply nitrogen combine to N2, but helium not combine to He2. So, number of question arises, what is the reason behind it? Why the shape of carbon dioxide is linear, where sulfur dioxide is angular. Similarly, ammonia is pyramidal, whereas boron trichloride is planar. So, number of questions arises in our mind. So, at first we see the approach taken by the scientist Kozel-Lewis approach. What is Kozel-Lewis approach to chemical bonding? First approach by scientist Kozel-Lewis approach. This theory is based on the electronic concept of atom. So it is also called electronic theory of valency atom. And it is called electronic theory of valency. Electronic theory of valency. We all know that the outermost shell is known as valence shell. This is known as valence shell, and electron present in it is known as valence electron. This is the outermost shell which is known as valence shell, and electron present in the valence shell is known as valence electron. So the nucleus plus inner electron. This nucleus plus inner electron means this to this, except outermost electron, except valence electron. Nucleus plus inner electron, nucleus plus inner shell electron is known as kernels. Kernel. Nucleus plus inner shell electron is known as kernel. Valence shell are not included in kernel. This electron is not included in kernel. So the positive charge present on the kernel is equal to the number of valence electron present in this shell. So this and we can write here also the units of positive charge. Kernel always positive charge, because the units of positive charge on kernel is equal to the number of valence electron. So students, I think you should understand about the kernel. What is kernel? The nucleus plus inner shell electron is known as kernel. Kernel always positive charge. And what is the reason for the positive charge? This is always positive charge. Kernel is always positively charged. And what is the reason for positive charge? The number of valence electron, which is not included in kernel. So number of valence electron, number of positive charge is equal to the number of valence electron. This is the reason for positively charge of kernel. So let's Lewis assume that outermost shell would accommodate at the maximum 8 electrons. 8 electrons. So according to this theory, the valency of element depends upon its electronic configuration, and it's called the electronic theory of valency or octet rule. According to this theory, the valency of an element depends upon its electronic configuration. So it is called electronic theory of valency or octet rule. Because Lewis assumed that outermost shell would accommodate at the maximum 8 electron. So according to this theory, electronic theory, which depends on the valency or octet rule. The main points of this theory is, student, the valency of element depend upon its electronic configuration. Means electron present in the outermost shell take part in the, suppose this is the electron which is known as valence electron. So according to this theory, The electron present in the outermost shell take part in the bond formation generally, and this electron which is present in outermost shell is known as valence electron, and it take part in the bond formation. And inert gases do not take part in bond formation. Take part in the bond formation. Yep. And so this shows that why inert gas not take part in the bond formation. So Lewis assumed that all the inert gas except helium has complete their octet, because they have outermost 8 electron present in their outermost shell. So this is the reason presence of 8 electron in the outermost orbits. This shows that this 8 electron gives the stability of that spaces, means they have stable configuration, and stable configuration means least energy. So this type of atom do not take part in chemical bonding. So this is the octet rule. Octet rule shows that element or species which have 8 electron in their outermost shell do not take part in the chemical bonding, means they have stable configuration. It's like all the electronic configuration of inert gases, for example helium, electron 2, and configuration. We all know that helium, after helium neon 10 electron, 2-8 configuration. Argon 18 electron, 2-8 configuration. Except helium, neon have 8 valence electron, argon have 8 valence electron. Similarly krypton, atomic number 36, configuration 2-8 18, again 8 comes. After krypton, see about xenon 54 atomic number, so 2-8 18 again 8 valence electron. And last, this is the radioactive element, but their octet configuration, it is considered in the noble gases group 18, 32, 18 and 8. So students, this thought that, or scientists thought that 8 valence electron make it stable, so that this type of species do not take part in the chemical reaction. So the other elements, they have not 8 electron in their valence shell, they try to complete their octet by different ways. So what are the different ways? So why spaces and how spaces complete their octet? At first, by the complete transfer of electron, one or more electrons from its valence shell, or by gaining one or more electron, or by gaining one or more electrons from the other atoms, and it is called the electrovalence or electrovalent bond. So the chemical bond formed by the lost or gained, here we write. So we can say that the chemical bond or attractive force exists by gaining or losing electron, means force exists between cation and anion. This type of chemical bond is known as electrovalent bond. Electrovalent bond. Electrovalent bond or ionic bond. We can say that another name of this compound is ionic bond. So when complete transfer of one electron, suppose this is species A and it has one valence electron, and this is species B and it has 7 valence electron. So this complete transfer of one electron to the B, and B gain one electron from the A. So there is a transfer of electron. In that condition, A becomes A positive and B, when gain electron, becomes B negative. So there is a attractive force exists between A and B. This type of attractive force is known as electro or simply ionic bond. It is called ionic bond because during this phenomenon formation of ions takes place. When the species complete lose their electron or complete transfer of electron, and another species which gain one or more electron from the other, in that condition the species which lose electron or acquire positive charge, the species which gain electron acquire negative charge. So it becomes cation, it becomes anion. So the attractive force exists between this cation and anion, and this type of force when formed, it is known as ionic bond or electrovalent bond. So this phenomenon is done by the species when they try to achieve octet configuration, because octet configuration makes stable. And second method to attain stable configuration means octet configuration or inert gas configuration by sharing of electrons. By sharing of electrons. It occurs by two ways. First, it is called covalent bond. Covalent bond is formed by the mutual sharing of electrons. Covalent bond is formed by the mutual sharing of electrons. Mutual sharing of electrons. Pair among combining atoms. Combining atoms. It is two types. First and second is called coordinate bond or dative bond. It is called covalent bond or dative bond. It is also a type of covalent bond. It is a type of covalent bond in which the electron pair is shared electron pair in which the shared electron pair is contributed by one of won't be discussed in details. Here only we simply explain how the condition and how the electrons gain octet rule by different ways. Now let's see the Lewis symbol. Lewis symbol simply represent the elements with their dots, and dots are the valence electron. Like lithium, the valence electron is 1. Beryllium, the valence electron is 2. Boron, the valence electron is 3. Carbon, the valence electron is 4. So these dots indicate the presence of valence electron. We all know the valence about the valence electron, means electron present in the outermost shell. So carbon, after carbon, nitrogen, the valence electron is 5. Oxygen, the valence electron is 6. Fluorine, the valence electron is 7, and neon, the valence electron is 8. So student, this type of symbol is known as Lewis symbol. What is the significance of Lewis symbol? So significance of Lewis symbols. If the number of electrons are, if the number of electrons are equal to 4 or less than 4 or less than 4, then common valency of the element is equal to the number of dots in the Lewis symbol. You have already read in class 10th students. And the second significance, if the number of dots are greater than 4, if the number of dots are greater than 4, for example, here we can write the common valency like lithium equal to dot valency 1, lithium, beryllium, boron, carbon. The valency is 1, 2, 3 and 4 respectively. If the number of dots are greater than 4, then the common valency is equal to 8 minus valence electron. 8 minus valence electron, or valence electron is what? Number of dots, because dots represent the valence electron, or we can say that 8 minus number of dots, or 8 minus number of dots. For example, nitrogen, oxygen, fluorine and neon. The valency of nitrogen is 8 minus valence electron. It becomes 3, oxygen 2, fluorine 8 minus the dots, number of dots, 8 minus number of dots. How many dots are there? So it comes 8 minus number of dots, it comes 1, and the valency of neon 8 minus dots becomes 0. So in this way we can find out the valency of given species by seeing the Lewis symbol, because this dot indicates the valence electron. So the rule is valence electron 1, valence electron 2, valence electron 3, valence electron 4, and dots 1, 2, 3 and 4 means their valency is equal to the number of dots. But when the dots becomes greater than 4, here nitrogen number of dots is 5, in the oxygen number of dots is 6, in fluorine number of dots is 7, in neon the number of dots is 8. So when it becomes more than 4, so we calculate the valency by the 8 minus number of dots. So it becomes valency, like nitrogen the valency is 3 because valence electron is 5, and 8 minus 5, so it becomes 3. So in this way you can, when you form the bond or form the molecules by different ways, so valence electron help to formation of compound. In the next video we will discuss the types of bond or types of way by which species attain the stable configuration. Means at first we will study about the electrovalent bond or ionic bond, in which the species complete either lose electron or transfer of electron takes place, and other species gain the electron. Means formation of cations and anions takes place when the transfer of electron and the gain of electrons takes place by loosening or by gaining. So we will discuss in the next video about the electrovalent bond